Okay guys, in this video we're looking at quadratic applications, so we're going to just apply the things that we've done so far in this chapter into a few extended questions and problem solving. So we've got this triangle, and we're wanting to work out the dimensions of the triangle. I want you to think about getting back into Pythagoras. A squared plus b squared equals c squared. And so here we have C, that is C, this is A, and this is B. So we're going to substitute everything into this equation. A squared is x minus 2 all squared, plus b squared, which is x plus 5 all squared, and C is 2x minus 1 all squared. If you are familiar with the patterns of expanding certain brackets, particularly perfect squares or difference of perfect squares, then it is going to be such an advantage to you in terms of time and efficiency. If you aren't familiar with that and you're still getting your head around it, then I suggest that you would stick to FOIL or crab claw, just traditional binomial expansion, and you will get to the same answer. It's just that if you find out patterns and you understand what to expect and predict, then it kind of saves you a lot of time. So I'm going to apply these patterns, but you can revert back to the previous videos to learn and to refresh your memories what they are all about. So x squared plus 4 minus 4x is the expansion of the first set of brackets, plus x squared plus 25 plus 10x is going to be the expansion of the second brackets. And then 4x squared plus 1 minus 4x is going to be the expansion of the last set of brackets. So now that we've got everything open, we're going to combine like terms. So we've got x squared and x squared, which is just 2x squared, minus 4x plus 10x is going to be 6x, and then 4 plus 25 is 29. So it's always helpful to rewrite everything so you can follow where you're going. I'm going to move everything to the left-hand side. Actually, I might move everything to the right-hand side because I'd like to keep things positive. So we're going to subtract, subtract, and subtract, okay? Leaving this side with 0. On the right-hand side, 4x squared minus 2x squared is just 2x squared. Minus 4x minus 6x is minus 10x. And then 1 minus 29 is minus 28. What I can see also is I can divide both sides by 2 to leave me with x squared minus 5x minus 14. So what I have here is a monic expression, knowing that I've taken out a common factor of 2 from all three terms. Now I need factors of 14 or negative 14 that add up to minus 5. I know my timetables, so it's going to be minus 7 and 2. So my answer is going to be x minus 7, x plus 2 is equal to 0. So because minus 7 plus 2 is minus 5, minus 7 times 2 is minus 14. Applying the null factor law, x minus 7 equals 0. X is going to be positive 7. And then x plus 2 equals 0. X is going to equal to minus 2. Now, if you think logically, you're never going to get a negative value for a side length of a shape. It's always going to be positive. So we are going to be giving credit to this answer, and minus 2 is not going to be a viable option for this context. So if x is equal to 7, a is going to be 7 minus 2. A is going to be 7 minus 2, which means a is equal to 5. If x is equal to 7, then b is 7 plus 5. b is then equal to 12. And if x is equal to 7, then we've got 2 times 7 minus 1. C is going to equal to 13. So they are our dimensions for this triangle. Okay. I'm going to move on to another diagram, which we have this rectangle. And so I'll just clear some space here. And we want the shaded area. Okay, we know that the area of a rectangle is base times height, but if we have 2x times x plus 2, but what's going on here is that if we actually multiply that, we are getting the area of this full rectangle. Okay, what we don't want is this little rectangle in the middle, so we need to take that away. So I'm going to subtract the area of the smaller rectangle, which is 3 times 6. Okay, so the area of the small rectangle is 3 times 6, which becomes 18. Okay, so I'm hoping this makes sense at the moment. If I put it into picture form, we want the big rectangle. That's not it's not a rectangle. Take away a smaller rectangle to give you the path that's around, shaded in the yellow. Okay, so here we go. We're going to multiply these two. Going to expand that, which is then 2x times x is 2x squared, and 2x times 2 is 4x. And we're going to subtract 3 times 6, which we've worked out was 18. What we do know is that the shaded area is 180 square units. Okay, so that is equal to 180. What we want to do is we're going to move this across to the left, and we can get our calculator here. So what's 180 minus 18? No, 180 minus 18 will give me 162. So, but we're subtracting. So we're going to have minus 198. It's always good to see. Remember the polarities. So if we're going to subtract minus 18 minus 180 is going to give us a bigger negative number. So 4x plus 2x squared. There we go. Great. What we can see is that all values are even. We can actually divide everything by 2. So we've got x squared plus 2x, and half of 198 is 99. Okay, so minus 99 is equal to 0. Now, this is where it comes to your timetables. Factors of 99 that add up, or negative 99 that add up to 2. It's going to be 11 and minus 9. So 11 times minus 9 is negative 99. 11 minus 9 is 2. So we can have our brackets as x plus 11, and then x minus 9 is equal to 0. So if you look at these two brackets and we apply the null factor law and we work out what our solutions are, you end up having these two scenarios. So x plus 11 is equal to 0, then x is equal to negative 11, or you have the other option, which is x minus 9 is equal to 0, so so x is equal to 9. And so just as what we've stated before with the triangle, that you can't have a negative value for, measurement and dimensions. So your answer is going to be x is equal to 9. Okay, so if x is equal to 9, then 2 times 9 is equal to 18. And then 9 plus 2 is equal to 11. Okay, so they are going to be our dimensions for those lengths, and that's our value for x. Well, in this case, the question is only asking you to solve for x, but let's say you were to work out what the dimensions of the path around, that is going to be the length of that path, that's going to be the length of that path. Now, if you let's move on to another question. I have one more. And here we have, I guess, a different scenario, but in this case, it's still a quadratic expression. The distance traveled by an accelerating skier is given by the formula d is equal to 3t plus t squared. So I'm just going to write that down. D is equal to 3t plus t squared. And d is in meters, and t is in seconds. Okay. If the distance traveled was 130, so if d was 130 meters, how long was the skier traveling? And we can then apply and put all of this in. So we'll have 3t. So I'm just going to put it into quadratic structure, having the squared term first, then the next term next, and then that's going to equal 130. Where we're going to go from here is we're going to move the 130 across to the left-hand side to form our quadratic expression. So t squared plus 3t minus 130, because this is positive, we're subtracting, that's going to equate to 0. So now what we want is factors of 130, negative 130, that adds up to 3. And I can immediately think of a positive 13 and a negative 10. So these two numbers multiply to negative 130. These two numbers, when put together, add up to 3. So if I were just to transfer things across to here, our brackets is going to be 10 plus 13, and then, t plus 13, and t minus 10 is equal to 0. Our solutions for t is equal to, and we can apply the null factor law, t plus 13 equals 0, so t is going to equal to minus 13, or we have t minus 10 equals 0, and t is then equal to positive 10. Again, context, think about logic here. We're talking about time, and the skier is accelerating. You're not going to have negative 13 seconds. That's not going to be possible. So your answer is going to be 10 seconds. Okay. So that's going to be the time for the skier traveling for that distance. If you have any questions, please let me know. Happy to help out. Otherwise, hopefully these examples help you in the process. Have a good day. See you in the next one.